Today we are going to discuss how to calculate rank correlation coefficient. So here in the problem he has given the ranking of 10 students in two different subjects A and B. So the ranking of 10 students in different subjects A and B. Okay. So in the first subject A, the first student rank is 6, and in the second subject the same student he got the rank 3rd. So in the second student rank is 5 in the A subject, his rank is 8 in the B subject. Third person rank in A subject is 3 and the rank in the B subject is 4, like that he has given. Then how to find out the calculate the correlation coefficient? Okay, the formula is 1 minus 6 sigma d square by n cube minus n. This is a formula where d stands for the difference between the ranks. Okay, so R1 and R2, we are framing the two columns. In the R1 I am writing the A subject ranks. Okay, that is 6, 5, 3, 10, 2, 4, 9, 7, 8, 1. Okay, in the second R2 I am writing the B subject ranks in the same order. Okay, so then I need d square. D square means R1 minus R2 whole square. 6 minus 3, 3 whole square 9. Similarly 5 minus 8, 3 whole square 9. Similarly 3 minus 4 whole square 1. Similarly, if you are doing like this, you are going to get these values. And if you add these entire values, this column, summation of this column comes as sigma d square equal to 36. Okay, so just you substitute these values in this one. 6 into sigma d square is 36, and we have given the ranks of 10 students. That's why n is 10, therefore 10 cube minus 10. If you simplify this one, you are going to get it as the 0.782. Therefore we can say that a positive correlation exists, okay, between the two subject ranks. Okay, thank you. Today we are going to discuss rank correlation coefficient. How to find out the rank correlation coefficient when the ranks are not given. When the ranks are not given. So he has given the raw data and the ranks are not given. Then how to find out the rank correlation coefficient? Always you have to remember that to find out the rank correlation coefficient, always you need the ranks. Okay, so first what I did is the debenture price. This debenture price I have taken it as the X column. So all these values I have written in the column wise, 97.8, 99.2, so on and so forth, up to 97.1. Now what is my aim is I have to give the ranks to this data. Similarly, I have written the Y values, that is nothing but the share price. Okay, next what I have to do is here the least value in the X column or the debenture price column is 96.7. so I have taken it, I have given the rank as 1. So next highest value is 97.1. I have given the rank it as 2. And the next value is 97.38, that is the rank 3. Next highest value is 98.3. I have given it as 4. So next highest value is 98.4, therefore 5th rank. Next 98.8, 6th rank. 99.2, 7th rank. Similarly, we have to give the ranks to the share price. Okay, here what you have adapted the procedure is, for the least value you have given the rank 1 and so on. So here also you have to adopt the same procedure. For the least value you have to give the rank as 1. 73.2 is the least value, consider this rank as 1. Next highest value is 75.8, give the rank as 2, and so on and so forth. From this onwards the problem will be simple. So next, difference of the ranks whole square. 3 minus 1, 2 whole square is 4. 7 minus 6, that is 1 whole square 1. 6 minus 4, it is 2 whole square 4. So on and so forth you are going to get like this. Okay. Next, the rank correlation coefficient formula is 1 minus 6 sigma d square by n cube minus n. Okay, sigma d square means the summation of this column is nothing but the sigma d square. So that is nothing but 6 into sigma d square. The summation of this column is 62. 62 by n, the number of values. Here it is the 7. Therefore 7 cube minus 7. If you simplify this one, you are going to get it as the r is equal to 0.107. That means there is a positive correlation exists. That is nothing but 0.107. So always you have to remember this formula. R is equal to 1 minus 6 sigma d square by n cube minus n. R correlation, rank correlation coefficient is 1 minus 6 sigma d square by n cube minus n. To find out the rank correlation coefficient, always require the ranks. That always you have to remember. Thank you. Today we are going to discuss how to calculate the rank correlation coefficient. How to calculate the rank correlation coefficient when the ranks are not given and the ranks are repeated. The ranks are not given and the ranks are repeated. How to find out the rank correlation coefficient? Okay. So the formula here it is, the rank correlation coefficient R is equal to 1 minus 6 into sigma d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m plus so on by n cube minus n. This is the formula. What I did is taken the x column and I have written the values from 48 to 57. Okay. Next, what I have to do is I have to give the ranks. So the least value is 9. I have given the rank as 1. After that one, the next highest value is 16. 16 here it will come across with the 1, 2, 3. 3 16s are there. Then how to give the rank to the 16? That is our question. So then what you have to do is here 3 16s are there. Let us consider for this one you have to give the second, this one third, you have to give the fourth rank. Let us assume. So what is the average of these ranks? Average of these ranks is 3. So what you have to do is for every 16 number you give the rank 3. Okay. So for 16 3, for this 16 3, and next this 16 also 3. Okay. So for the next highest number, that is 24. For 24, which rank you have to give? Here 2, 3, 4 ranks are over. Therefore you start with 5. Okay. Next highest after 24, the number is 33. Therefore you give it as 6. Okay. Next highest value 40, you give it as 7. Next 8, 9, 10, like that. Okay. Similarly, the data of y, you write it in a column model. Next, what you have to do is the least value you give the rank as 1. Next, the highest value is how much? Let us consider 6 and 6. Okay, the next highest value is 6. So after 1, what are the ranks you are going to get? 2 and 3. Therefore, you give it as the 2 and 3. Okay, so what the ranks you have to give for these 6 means average of these two, that is nothing but 2.5 and 2.5. Okay, next to highest value is what after 6? It is 13. Okay, 13. Next here it is 9. For 9 you are going to get it as the 4, because 2 3 ranks are over, therefore you are going to get it as 4. Next 13 we have the two numbers, therefore next rank you have to give this one as 5. For this one you have to give it as 6. Okay, so the average of these ranks is 5.5. for these two you have to give it as the ranks as 5.5. so now 6th rank is completed, we have given. So next highest value is what? Next highest value is 15. For this one you have to give which rank? 7 you have to give. Similarly you have to give the remaining ranks to the given numbers. So next what you have to do is the difference in ranks. 8 minus 5.5 whole square, you are going to get it as 6.25, and so on and so forth. So if you add this one, this value is nothing but sigma d square, difference in the ranks. Okay, next here we need the m value. So m value, how will you get m? The m value means here 16 is repeated how many times? 1 2 3, therefore 16 is repeated 3 times. You note down. Next here it is 2 is repeated, sorry 6 is repeated 2 times. I have written 13 is repeated 2 times. Then how to substitute in the formula? 1 minus 6 into sigma d square is 41 plus 16 is repeated 3 times, therefore you write 3 cube minus 3 by 12. Next 2 times, therefore 2 cube minus 2 by 12. Next again it is 2 times, therefore 2 cube minus 2 by 12. If you simplify this one by n cube minus n. Okay, if you simplify this one you are going to get it as the 0.733. 0.733. 1 minus 6 sigma d square, 6 into sigma d square plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m, so on. Here divided by n cube minus n. N cube minus n. So how many values are there? 1 2 3 4 5 6 7 8 9 10. Therefore you are going to get the denominator as 10 cube minus 10. You are going to get the rank correlation coefficient is 0.733. Okay, that is nothing but a positive correlation exists between the x and y. Okay, thank you. Today we are going to discuss regression equation problem. So here he has given the age versus the blood pressure data he has given. We have to find out a regression equation y on x and find the expected blood pressure of a person who is 49 years old. That means for 52 age it is the blood pressure is 62, for 63 it is 53, like that he has given the data. For 49 years old of a person, what is the blood pressure we have to find out using the regression equation. So for that one, the regression equation y on x is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Okay, where r into sigma y by sigma x is equal to n into sigma dx dy minus sigma dx into sigma dy by n into sigma dy square minus sigma dy whole square. Here one more thing, x bar, this x bar is nothing but sigma x by n. Similarly y bar stands for sigma y by n, where dx stands for x minus assumed mean, dy stands for y minus assumed mean. So till now what we have discussed is the regression equation y on x and what are the x bar, y bar, dx, dy, like that we have discussed. Next, what you have to do is for the formula, what are the required columns that I am defining: x and dx square. Okay. Similarly, y dy square and dx dy. So in x I am going to write the age values. Okay. Similarly, I am considering the assumed mean as 50. You can consider the assumed mean whichever you like. That is not a problem. You have to consider the assumed mean as you like. Here I am considering it as 50. So 52 minus 50 plus 2. Similarly, 63 minus 50 plus 13. Similarly, 45 minus 50 minus 5, and so on and so forth. Dx square, 2 square 4, 13 square 169, and 5 square 25, so on. 25 whole square is 625. Similarly, I have written the y, nothing but blood pressure values here. Now dy is equal to y minus assumed mean. Assumed mean I am considering it as 50. You can consider the assumed mean as whatever you like. Here I am considering it as 50. 62 minus 50 plus 12, 53 minus 50 plus 3, so on and so forth. 33 minus 50 plus minus 17. Similarly, dy square, 144, 9, 1, 625, 17 whole square 289. Similarly, dx into dy, 4 dx is 2, dy is 12, 12 into 2, 24 plus 24, plus 13 into plus 3 plus 39, and so on and so forth. So I have completed the table. Now what are the sigma x is 405, sigma dx is plus 5, sigma dx square is 1737, sigma y 406, sigma dy plus 6, sigma dx dy is 1336. So from this one we have to conclude x bar. This is the sigma x only. X bar is sigma x by n, 405 by 8. That is nothing but 50.625. Sigma y by n, 406 by 8, that is 50.75. So in the regression equation formula we require this one first. Therefore r into sigma y by sigma x is equal to, this is the formula. So n stands for, n is equal to how much? Number of values is 8. Therefore 8 into sigma dx dy 1336 minus sigma dx is 5, sigma dy stands for 6 by n again 8, sigma dx square is 1737 minus sigma dx is 5 whole square. So if you simplify this one, you are going to get it as 0.76. So regression equation y on x is the formula y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Already we have completed this value. This value is nothing but 0.76. So y minus y bar, already we did that one, 50.75 equal to 0.76. This is the value of r into sigma y by sigma x. X minus x bar value is 50.625. If you do that one, y is equal to 11.87 plus 0.768 times x. We have to find out the blood pressure of a person having 49 years old. That means x is 49. Therefore in place of x you substitute 49, you are going to get the y value. Therefore y value you are going to get it as 49.502. Therefore for 49 years old person the blood pressure is 49.502. Okay, so this is about the main one. You have to remember this formula, y minus y bar equal to r into sigma y by sigma x into x minus x bar. where r into sigma y by sigma x is, this is the formula. Okay, this is main important. Okay, thank you.